Today we're going to talk about geometric sequencing. This will be the last section. We're skipping the next one about recursive. So this will be the last section of our chapter. So then you're going to have a big week, and then we'll review a little bit before we move on. All right, so don't forget everything. Okay. An arithmetic sequence you've already had is a sequence where the numbers are added or subtracted, which is basically adding a negative. The common value is known as a common difference, and we use the variable d. Geometric sequence is when you multiply by the same value. R is the factor you're multiplying each term. If the fraction is if the term's getting smaller, you're multiplying by a fraction. So if you're dividing by 2, you're actually multiplying by 1/2. So your common ratio is 1/2. Okay, you're not dividing, you're multiplying. So you have to write it as a fraction. So if you're dividing by 3, you're actually multiplying by 1/3. All right. Determine whether each sequence is arithmetic or geometric. Find the next three terms and what is the common ratio. So let's see here. 0, 5, 10, 15, 20. Hopefully you guys know the next 3 terms. And your common ratio is not a ratio. Your common difference is 5. So that is arithmetic. Those are your next 3 terms. And your common ratio is not a ratio, it's a common difference, and it is 5. All right, my next one, 1 to 5, 5 to 25, 25 to 125. I know I'm multiplying by 5 each time. So that means this is geometric. My next 3 terms are, I'm going to use my calculator. So I don't feel like doing all that multiplication. 625 times 5 times 5 times 5. And my common ratio, it is a common ratio this time, is 5. All right, you do the next one. See if you can get it figured out. Hit pause. Hit play when you're done. All right, so this is geometric. My next 3 terms are negative 32, positive 64. I could have done those in my head. Negative 128. So I multiplied each one by 2. My common ratio is negative 2. All right, here's my last one. So from 60 to 72, I'm adding 12. From 72 to 86 and 4/10, I'm adding 14 and 4/10. There's 12. So it's obviously not arithmetic, but is it geometric? Okay. The fact that you've got 1 decimal but the other 2 are not, that's worrying me. Okay, so I'm going to divide this number by this number. 86 and 4/10 divided by 72 equals, and that tells me I actually multiplied by 1 and 2/10. So 72 times 1 and 2/10 equals 86.4, yes. So now I'm going to see if 72 divided by 60, oh, it also is 1 and 2/10. So now I know what it is. It's geometric. My next 3 terms, so I am actually multiplying by 1 and 2/10. So 86 and 4/10 times 1 and 2/10, 103 and 68/100 times 1 and 2/10, 124 and 416 thousandths times 1 and 2/10, All right, so my common ratio is 1 and 2/10. All right, so once again, and in order to figure that out, so I first looked to see if it was arithmetic, but obviously it's not. So then I took this number divided by this number. So then that would tell me what this one's being multiplied by, because they're inverse operations. So we've done that before, so hopefully you figured it out. This number divided by this number, 72 divided by 60, tells you what 60 is being, shoot, I put that there and I didn't mean that there. 72 divided by 60, I said the right thing, but I wrote the wrong thing, equals some number. So that means 60 times that number equals 72. So you know how those are inverse operations, that's their little fact family. To graph a geometric sequence, create a table. The x value is the position and the y value is the number in that position, and that should be a subscript n. And this should be a subscript n as well. So your coordinate pair is n, that's your position, a subscript n, that's the number in that position. So this number is your y. That is your value. And that is the first number, so that is going to be a 1. My second number is 16. My third number is 8. My fourth number is 4. And my fifth number is 2. So there are your ordered pairs. And now I'm writing them actually as ordered pairs. And you're going to upload a picture of the graph on the next slide. So the common ratio, what do you multiply this to get here? All right, so I see I'm actually dividing each one by 2, but that's not what they're asking me for. So if I'm dividing by 2, it means I'm multiplying by a fraction of 1/2. Okay, so remember that if it's smaller and you're dividing, you're multiplying by a fraction. So the common ratio is 1/2. You have to type it, so go ahead and do the backslash like that. Okay, now my next slide, I am going to graph these, so I'm keeping them on somewhere on a piece of paper or something so I don't keep going back and forth. Oh, I wrote down the numbers again, so I didn't have to worry about that. All right, so let's see here. My largest number on my x is a 30, no, my y's. My largest one's a 32, so I'm going to count by 4s. So that's going to be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. Oh, I don't need to go that high. I need to go as high as 32. So these I'm going to go by 1s. Okay, 1/32, that's there. 2, 16, 3, 8, 4, 4, 5, 2. When you are graphing these, do not join them. They are discrete. They're not continuous because you don't have 1.5 positions. You only have 1 position, 2 position, 3 position. So they can't be connected. Keep going. Okay, this is an explanation as to how we get this formula. This formula is one you're going to use. So if you want to know how we get it, this is how. This is an example. So this 2 is your first term, 6 is your second term, 18 is your third term. This is how you write which term it is. A to the subscript 4 is your 54. Whatever term it is, a subscript n. Okay. Or the first term times your common ratio. Then 18 is your second term times your common ratio. So it's 6 times 3. Then this is your term before times your common ratio, which gets you 54, that number up there. So using this, whatever term you want times, I think it should be term before. Yeah, it should be term before. Times your common ratio gets you the nth term. But for this one to work, you have to know what the term is right before where you're looking at it. This formula, you can figure out any term as long as you know the first term and your common ratio. Remember, r to the 0 power is 1. So your first term is your first term, because first term times 1 is itself. Okay, then your second term is your first term times your ratio to the first power. So let's see here. My common ratio is times 3. So this would be 2 times 3 to the first power, which is 6. This would be 2 times 3 to the second power, which is 18. This is 2 times 3 to the third power. 3 to the third power is 27. 27 times 2 is 54. So you can find any location as long as you know the first term and your common ratio. And this is the formula for any term. First term times common ratio, whatever position your n is, minus 1. Okay, so that's long explanation as to how these formulas work. Here's the formula. For the nth term, this is any term. The nth term is equal to the first term times your common ratio to the whatever term you're looking for minus 1. So that's what each of those variables are defined as. So let's use it in action. All right, so our formula is a subscript n equals your first term times your common ratio to whatever term you're looking for minus 1. So I need to know, I have to know these for sure. So my first term is 1. My common ratio, what do I do each time? Times negative 5. So my common ratio is negative 5. So now I'm ready for my nth term. So my nth term is equal to my first term times my common ratio, and I put that in parentheses because that is a negative 5. That's not a negative 1 times 5. To the n minus 1 power, you can simplify this one because 1 times anything is itself. If you leave the 1 there, you're fine. Okay, now the second part. So they want to find the 7th term, which is a subscript 7. So now I know n equals 7. So a subscript 7, the 7th term, is equal to negative 5 to the 7 minus 1 power. Negative 5 to the 6th power. So I'm using my calculator. I type in negative 5, an exponent of 6, and it tells me that my 7th term is 15,625. Okay, so that's actually my answer. And that's the answer to the second part. Okay, so when you're looking at a story problem, in order to write an equation to the nth term, you have to have your first term and your common ratio. All right, so read the story problem. King offered a beggar fabulous meals for 1 week. Instead, the beggar asked for a single grain of rice on the first day. So first day, I now know my first term is a 1 grain of rice. My second day, so I'm going to start with the 1. My second day, it's doubled each time. So that means my R is 2. I didn't need to write my second one. 1 to 2, but then it didn't tell me other. But it told me right here that it's doubled each day, so that's what I needed. Okay, so for the nth term, a subscript n equals first term times r to the n minus 1 power. So that means my n is going to stay as an n. My first term is 1. My r is a 2. N minus 1. You can also have either one's fine for me. Okay, so now we want to know the 30th day. So that means we know our n is going to be 30. So the 30th day is equal to 2, parentheses, 30 minus 1. So the 30th day is equal to 2 to the 29th power. So using your calculator, 2 raised to the 29th power, you have, oops, okay, let's see here. 1,073,741,821 grains of rice. I'm going to write my sentence. The beggar will receive 1,073,741,821 grains of rice, period. All right. Pretty smart beggar, huh? And that is it.